For years, my work as a physicist was all about the comets and asteroids born right here, in our own cosmic backyard. But then 2017 happened. Everything changed. We got our first confirmed visitor from another star system, and honestly, it kicked off a whole new chapter for astronomy. So, we call these things interstellar objects, which is the technical term, but they're so much more than just space rocks. Really, you should think of them as messengers, carrying secrets from unimaginably distant worlds. So let's dive in. What exactly are they, and why are scientists like me so incredibly excited about them?
The dead giveaway, the thing that tells us they're not from around here, is their past. All of our local stuff, our planets, asteroids, comets, they're all locked in orbits around the sun. But these visitors, they're on what we call a hyperbolic path. Basically, it's a one-way ticket. It's the cosmic signature that proves they're just passing through, never to return.
And that's exactly what makes them so thrilling. I mean, think about it. Each one of these visitors is a literal, physical piece of another star system. It's a cosmic time capsule, packed with clues about how other planets might have formed maybe billions of years ago. It's like getting a geological sample from an alien world delivered right to our doorstep for free.
Okay, so up to now, we've confirmed exactly 3 of these interstellar travelers. Now I know, 3 doesn't sound like a lot, but let me tell you, each one has told us a completely different and sometimes totally baffling story about what's going on out there in our galaxy. So our journey really kicks off in 2017 with Oumuamua, which was a true enigma. Then, just 2 years later, we met Borisov, which felt a little more familiar. And now we have Atlas teaching us even more. The pace of discovery is just picking up like crazy, and it's incredible to be a part of. The first one was given this beautiful Hawaiian name, Oumuamua, which means a messenger from afar. And boy, did it live up to that name. From the absolute moment we saw it, it broke every rule we had for what an interstellar visitor was supposed to look like. So this ratio, 10:1, hints at just how bizarre its shape was. As it tumbled through space, its brightness changed so much that astronomers figured it had to be at least 10 times longer than it was wide. Imagine a cigar, or maybe a really, really flat pancake. We had never, ever seen anything like it. And the mysteries just kept piling up. It had this reddish, rocky look to it, but there was no fuzzy cloud of gas around it, what we call a coma, like you see with a comet. And yet, and this is the really weird part, it was speeding up as it moved away from the sun, like something was giving it a gentle push. But we couldn't see any rocket-like jets of gas. This one puzzle, right here, sparked one of the biggest debates in modern astronomy. So 2 years go by, we're all still scratching our heads about Oumuamua, and then a second object shows up. This one was actually found by an amateur astronomer, Gennady Borisov, and it looked surprisingly normal. I mean, the contrast between the two was just stark. Oumuamua was this strange, inert, rocky thing. But 2I Borisov? It was clearly a comet. It had a bright coma, a beautiful tail, and its chemical makeup looked a lot like the comets from right here in our own solar system. And that was profound. It suggested that maybe, just maybe, the building blocks for planets are pretty similar across different star systems. And that brings us to our newest visitor, 3I/Atlas. What was great about this one is that we spotted it on its way into the solar system. For the first time, we had a heads up, giving us precious time to get all our best telescopes pointed at it and study it like never before. Just look at that number. It represents its unbelievable speed. 3I/Atlas is the fastest thing we've ever seen visit us, blazing through our system at nearly 60 kilometers a second. Now, an object doesn't get moving that fast without having been traveling through the galaxy for a very, very long time. In fact, that incredible speed suggests it could be an ancient relic, maybe as old as 10 billion years. Just think about that for a second. This object might have formed around one of the very first stars in our galaxy, way before our own sun even existed. It's like a true pilgrim from the dawn of the Milky Way. Okay, so let's recap. We've got a bizarre rock, a pretty normal comet, and an ancient, super fast comet. With 3 of them now in the books, we can finally start to compare them, to connect the dots, and ask some bigger questions. What are these messengers together trying to tell us? This chart really lays out just how different they are. You've got one that looks like an asteroid and 2 that look like comets, but each one brought its own unique puzzle to the table.
Oumuamua's weird acceleration, Borisov's incredibly pristine condition, and Atlas's record-breaking speed. If anything, it tells us that the story of how planets form across the galaxy is way more diverse and complicated than we ever imagined.
Of course, when you have an object as strange as Oumuamua, it was really only a matter of time before someone asked the big question. Was it natural, or was it something else? Its weird shape and that unexplained push just blurred the line between science and science fiction. So some scientists, and the most famous voice here is definitely Harvard's Avi Loeb, argued that we just can't dismiss the possibility that it was artificial. He put forward the idea that Oumuamua could be some kind of alien technology, like a solar sail, and that it's our scientific duty to investigate every anomaly, no matter how wild the explanation might seem. Now, while that debate was absolutely fascinating, the broader scientific community has really focused on finding natural explanations, and a few really compelling ideas have come up. Some think it was a nitrogen iceberg, a chip off an alien Pluto. But a leading theory now suggests that as the sun warmed it, trapped hydrogen gas was released from its water ice. This would have created invisible jets, giving it that mysterious push. A totally natural process, but one we'd just never seen before. The arrival of these three objects has been a huge wake-up call for us. We've realized these aren't just once-in-a-lifetime events. It's a steady stream of visitors, and that poses a massive technological challenge. So how are we getting ready for the next one? First, you have to appreciate just how hard this is. These objects are incredibly faint, they're moving incredibly fast, and they're usually gone from our view within just a few months. That means we need early detection and a super rapid response from telescopes all over the world. It is a genuine race against time. To meet this challenge, the European Space Agency is developing this brilliant mission called Comet Interceptor. Instead of picking a target before you launch, which is how we always do it, this spacecraft will launch and just park in space and wait. It'll lie in wait, and when the next great interstellar object is found, it will fire its engines and fly out to meet it. We'll get our first ever close-up look. It's basically a cosmic ambush. And this is where the future gets really, really exciting. We have new eyes on the sky coming online, like the Varici-Rubin Observatory, and they are total game changers. We're talking about going from finding one of these objects every few years to maybe finding them every few months. We are right on the verge of turning these super rare discoveries into routine observations. Oumuamua showed us to expect the unexpected. Borisov showed us that we might have cosmic cousins out there. And Atlas showed us that ancient relics from the dawn of the galaxy are actually visiting us. Each messenger has totally changed our perspective. And now, as we stand on the cusp of finding so many more, it just leaves you with this one thrilling question. What profound secrets will the next one carry from the stars?